In public key encryption systems, any person can encrypt a message using a receiver's public key. That encrypted message can only be decrypted with the receiver's private key. So to be practical, the generation of a public and private key pair must be computationally economical. Now, the strength of a public key cryptographic system relies on computational effort or the work factor in cryptography that is required to find the private key from its pair's public key. So effectively, security only requires keeping the private key private, and the public key can be distributed without compromising security. Public key cryptography systems often rely on cryptographic algorithms based on mathematical problems, particularly those inherent in certain integer factorization, discrete logarithms, and elliptic curve relationships. Public key algorithms, unlike symmetric key algorithms, do not require a secure channel for initial exchange of one or more secret keys between the two parties. So because of the computational complexity of asymmetric encryption, it is usually used only for small blocks of data, typically the transfer of a symmetric key encryption system. This symmetric key is then used to encrypt the rest of the potentially long message sequence, and the symmetric key encryption and decryption is based on a simpler algorithm that works much faster. So because of the computational complexity of asymmetric encryption, it is usually used only for small blocks of data, typically the transfer of a symmetric encryption key. Example is session key. Now this symmetric key is then used to encrypt the rest of the potentially long message sequence, and the symmetric encryption and decryption is based on simpler algorithms that is much faster. Okay, so now it's time for an interesting demo on why you actually should really be aware of cybersecurity. So for this demonstration, I'm going to be showing you guys a man-in-the-middle attack. So for the man-in-the-middle attack, as we earlier discussed, we are going to need to ARP spoof ourselves to another computer and ARP spoof ourselves to the router too. So that means we are going to fool the computer that we are the router, and then we're going to fool the router that we are the computer. So for this demo, I'm going to be using two machines. One is going to be running Linux, and on the Linux-based machine, I'm going to be performing the attack. And for the victim, I've chosen it to be my own machine. And for the results, you guys will see how I'm going to sniff out all the images that is being served on the victim machine. So for this demonstration, we are going to be using a framework called Websploit. Now, Websploit is an open source framework and it's easily available on Linux, and it can help simulate man-in-the-middle attacks just for educational purposes. So let's get started. So first of all, we are going to start up Websploit by typing in the command Websploit. So once you go into Websploit, you go show modules. So as you guys can see, we have so many modules available out here. And these are all the types of attacks that you could possibly simulate with this framework. So we're going to choose the man-in-the-middle attack. So that is, we're going to use network/MITM. So now out here, you're going to see all the options that we're having. So as you guys can see out here, the Websploit framework gives us numerous amounts of options to set up. First, we can set the interface that we're going to attack on, and then we can also set the router that we're going to attack through. Then we can set the target IP address, and we can also set from a number of different sniffers. For example, we can use DriftNet for sniffing out victim images. We can use URL snarf for sniffing out victim links. Then we can use dsniff for sniffing out all sorts of passwords. Also, we're going to use SSL strip for actually stripping down SSL protocols so that you're not actually visiting a secure site. So firstly, we need the IP address of our victim's computer. So I'm going to go on my computer and check out my password. So ipconfig. So as you guys can see, my password out here is 192.168.2.142, and my default gateway is 192.168.1.1. So that means my computer, this is .2.142, is connecting to the router, which is then connecting to the rest of the internet through 192.168.1.1. So to check out my attacking computer's IP address, we're going to go ifconfig, and we see that we're running on the interface WLP2SO. You can also check that by going route-n, and this will show you the gateway that it's 192.168.1.1 out here, as you guys can see. And our IP address is out here, 192.168.1.215. So this is our attacking IP address. So moving on to Websploit now. Okay, so first we need to set our interface. So we go set interface. So that sets our interface. Then we need to set the target, as the router IP address is already correct. So our target is going to be 192.168.2.142. 192.168.2.142. And we're going to use the DriftNet sniffer for sniffing out all the victim images. And SSL is true, so let's just check we've got everything correctly. Show options. So yes, our interface has been set, our router has been set, the target has been set, we've set our sniffer, and SSL stripping is on. So all we have to do now is run our attack. So first we're going to forward all the IP. Now we're going to ARP spoof it. That's going to just lie on the network that we're somebody else. So now that we've run the attack on our attacking computer, it's time we go and browse some images on Google. So let's look at some images of Lamborghinis. So let's search for Lamborghini. So as you guys can see, it'll sniffing out all the images of all the Lamborghinis that I'm looking at out here. Like this Lamborghini looks really cool. This crashed one. There's so many Lamborghinis to look at. So as you guys can see, whatever images that you're looking at is just being sniffed out of the network, and I can see them as well as an attacker. So this gives you a measure of the magnitude of information that can be stolen from you just through a simple man-in-the-middle attack that can be actually performed with regular softwares that are available for open source use. Okay, so that was it for